Hey everyone, and welcome. So, today we're going on a bit of a quest. Our mission? To crack the fundamental code of one of the most important shapes in our world, the triangle. We're going to figure out the absolute bare minimum you need to know to build one perfect, unique triangle every single time. All right, let's dive right in. You know, our whole story kicks off right after a storm. Just picture it, a giant tree, snapped right in half, leaning against a wall and forming this perfect, beautiful triangle. It's like nature doing geometry for us. And this scene, it sets up a really fascinating problem.
So let's say you had to recreate that exact triangle, maybe for an engineering model or even a sculpture. What would you actually need to measure? Do you need all the side lengths, every single angle? What's the secret code, the blueprint that unlocks one unique triangle? That's the puzzle we're going to solve today.
Okay, but before we can even think about building triangles, we've got to master one fundamental skill. Think of this as the first and most important tool in our geometry toolkit. Getting this right is the foundation for everything else, because it lets us copy angles perfectly, and that's a huge part of our triangle recipes.
So, what exactly are parallel lines? Well, they're two lines that, if they went on forever, would never, ever cross. Simple enough, right? And the rule that proves it is just as simple. If you draw a third line that cuts across them, we call that a transversal, the angles on the inside, on opposite sides of that cut, they have to be exactly equal. That's the telltale sign.
And check this out, this is how we actually do it with just a ruler and compass. You draw your first line, and then a transversal. Then, you use your compass to perfectly copy that angle from the first intersection up to your new point. Draw a line through that copied angle, and boom, you've got a perfectly parallel line. It almost feels like a magic trick, but it's just pure geometry. This skill, copying an angle precisely, is absolutely crucial, and you're about to see why.
All right, toolkit's ready, we've got our skills sharpened, now we can finally get to the main event. We're about to pull back the curtain on the 4 secret codes. I like to call them the 4 proven recipes for building any triangle you want with total precision. Let's open up the blueprints. And here they are, the big 4, SS, SS, ASA, and the special one, RHS. These are the only 4 combinations of 3 measurements you will ever need. If you have the info for any one of these sets, you can build one, and only one, possible triangle. It's like a guarantee.
First up, we've got the one that probably makes the most sense right off the bat. SSS, or side, side, side. The idea is super simple. If you know how long all 3 sides are, that triangle's shape is completely locked in. There's no other way it can be built.
And here's how that works. You just draw your base, say 5 centimeters. Then from one end, you swing an arc of 4 centimeters. From the other end, you swing an arc of 6. And right there, where those 2 arcs cross, that is the only possible place in the universe for that third corner to be. It's totally defined.
Okay, recipe number 2 is SAS, side, angle, side. For this one, you need to know the length of 2 sides, but also, and this is so important, the angle that's squished right between them. That included angle is the absolute key that makes this whole thing work.
Let's see it in action. We draw our 5 centimeter base, then, at one end, we carefully build our 30-degree angle. That gives us a path heading off into space. Now we just measure exactly 4 centimeters along that path, and there's our third point. It's fixed. All you have to do is connect it back to the beginning, and your unique triangle is done. Moving on to recipe number 3, ASA, or angle side angle. This time, what we know are 2 angles and the one side that connects them. So that side becomes our solid foundation, and the angles at each end tell us exactly where the other 2 sides have to go. You know, this one is just so cool to visualize. You lay down that 5 centimeter side. From one end, you shoot out a line at an 80-degree angle. From the other, you shoot a line out at 40 degrees. These 2 lines are now on a collision course, and there is only one single point where they can possibly meet. That intersection is the third corner of your triangle. No guesswork needed, it's guaranteed.
And finally, our special case, RHS. That stands for right angle hypotenuse side. This is the go-to recipe for any right-angled triangle, which, let's be honest, are the backbone of basically all construction and engineering. For this, you need that 90-degree angle, the longest side opposite it, the hypotenuse, and just one of the other sides.
So, how does this one lock into place? Well, you draw your 8 centimeter base, and then you build a line going straight up at a perfect 90-degree angle. We don't know how tall it is yet.
But then, from the other end of the base, you swing an arc that's 10 centimeters long, the length of your hypotenuse. That arc can only cross the vertical line at one single spot, and that spot locks in your final point. So simple, so powerful, and just incredibly useful.
So there you have it. We've got our tools, we've got our 4 master recipes, we've cracked the code. But now let's zoom out a bit. Let's connect this all back to that fallen tree and really the whole world around us. What's the big picture here?
So why does all this matter? What's the big takeaway? It all comes down to one word: rigidity. Because a triangle's shape is totally locked in by just 3 pieces of information, it refuses to bend or twist or warp. That natural stability isn't just a neat fact for a math class. No way. It is the fundamental principle that lets us build everything, from the trusses in a roof to massive bridges and towering skyscrapers. The strength you see all around you, it's built on these geometric codes we just walked through. So we've cracked the code for the triangle. But of course, that's just one shape. So I'll leave you with a question to chew on. As you look around you today, what are the secret codes, the minimum rules that define the perfect circles, the sturdy squares, and the soaring arches that make up the rest of our world? The blueprint is everywhere. You just have to know how to look for it.